quality of education teaching and utmost care about the students. We do have all the state of art of the infrastructure to the benefit of the society and students. We inculcate a quality of teaching methodologies for the young students. Let me introduce today's speaker, Dr. M. Tirmalachari Garu. Sir is Professor and HOD, Department of Chemistry, JNTH, Hyderabad. Sir is Chairman, CRC, BTech first year, JNTH, College of Engineering, Hyderabad. Sir is also Chairman, Board of Studies in JNTH, Hyderabad. Sir is having vast teaching and research experience of more than 33 years. Maharashtra. Sir has also worked for some period in Maharashtra. Earlier, Sir has worked as Vice Principal, JNTH, College of Engineering, Jagityal, from the year 2010 to 2012. And also as Principal of JNTH, College of Engineering, Jagityal, from 2012 to 2015. Sir, interest area of teaching includes environmental, meaning synthesis of heterocyclic moieties, synthesis and antimicrobial ability of 1 to 8, naphthalides, synthesis and biological assay of quinzoline derivatives. Dr. M. Tirmalachari Garu is an eminent personality in Telangana region. Sir has given more than 100 guest lectures in Indian universities and technical institutions. Sir has visited Canada, Indonesia, and Sri Lanka to give guest lectures and also publish papers in international conference at Canada. So it's a great thing. Sir has guided more than 20 PhD scholars. It's a really great achievement, and still Sir is guiding scholars. Published more than 150 research papers in prominent international journals and conferences. Sir has organized more than 10 faculty development programs, short-term courses, conferences, and also, to his credit, authored 3 textbooks. Sir is very soft-spoken person. At any given time, Sir come forward to help the students, those in need of any requirements, either maybe the personal doubts or any career growth or any subject related doubts. Never hesitate to help any persons. As I said, in Telangana zone, particularly in technical institutions, Sir is a very prominent person. With these few words of introduction about today's speaker, Dr. M. Tirmalachari Garu, I would like to invite him. Please continue the session. Thank you very much, sir, for accepting with a short notice period of time. Thank you very much, sir.
Thank you, Dr. Srinivas, for your kind words. I don't know whether I'm eligible for such kind of superlative words. Very kind of you. Thank you so much.
Yes.
And at the outset, I would like to thank the principal, Wagifiri College of Engineering, Karimnagar, and also the management, having given me an opportunity to be the speaker for the webinar. I welcome all the delegates. I say good morning to you all, and I wish you all safe in this pandemic situation. Please be safe and be healthy, be hale and hearty. And let us go to the academic business. I have chosen the topic for the webinar is corrosion and traditional practices of its prevention. Let us start with a big question mark. Why exactly the corrosion is to be studied? Why it is important? And how it is associated with the human life? And with this question, let us proceed further. In coming about 2 to 3 minutes, I will show you some of the incidents happened due to the corrosion, or they are associated with the corrosion. This is the photograph of the Bhopal gas incident. This has happened on the second night of December in 1984. The Union Carbide Company, a multinational company, which was manufacturing the pesticides in big tanks. They have stored the methyl isocyanate gas. And any issue, please?
Slide
Srinivas?
Sir?
Any problem?
Nothing, sir. Nothing, sir. Nothing. Please go ahead.
Okay.
No issue, sir.
The Union Carbide Company has stored methyl isocyanate gas, which is very poisonous, in the liquid state in the high pressures in the tanks, and the gas has leaked out, and which has killed about more than 25,000 people in and around the Bhopal city. Why? I'll look at that the human life is very precious, and older people used to say after about 1 lakh of births, a creature will get the birth of human life. And if this human life is stopped or broken at this by the simple problems or with the human errors, it is very pathetic. This Bhopal gas or the methyl isocyanate gas has killed more than 25,000 people, and the rudiments of these effect is still there in the progeny. The people or the kids are getting birth still in this year with the deformity in their limbs, in their organs, and in their body. Why? Why this should be happened? Let us look at another slide in which you are looking at a train accident. That train accident took place on June 6th, 1981, and a passenger carrying the people in Bihar. The train was derailed between Mansi and Sahasra railway stations, and which has killed around more than 800 people. And why this accident has happened? And again, the reason is associated with the corrosion. In the earlier case, in the methyl isocyanate gas release or leak has happened because of there was a small part of the groove of the cylinders or the tanks was undergone corrosion, and as that small part was under pressure of the methyl isocyanate gas, that was loosened, and a pore appeared, and with the high pressure of the methyl isocyanate gas, which was gushing out from a small hole, the diameter is increased and the lid was thrown away, and then the gas has come out, which was killed about more than 25,000 people. And in this case, the fish plate, which was corroded, and if any small part of the fish plate is corroded, there will be an imbalance in the track, and then as the weight of the train is very high, that was the fish plate was broken and this was derailed and killing about 800 people. Again, this is associated with corrosion. Now let us look at another incident. Of course, many people were not dead in this event. This is happened in the Florida in USA. A gas accident has happened, and with this the gas caught fire and huge flames came out, and with this the temperature has increased enormously in and around that storage and killed many birds, and it caused some ill health in the inmates around the people in the area. And I'll show you one more slide. This is a ship, a big ship by name Erica, which was sank off the coast in the Brittany, dumping around 31,000 barrels of the fuel into the Atlantic Ocean, which has happened on the December 8th, 1999. What happens if the oil is spilled into the sea? And this oil which was spilled, along with the tides, it reaches the shores, and it has formed a layer over the water and disturbed the activity of the aquatic animals. Millions of fish were dead, and you see many aquatic animals like a starfish, crabs, etc. were dead and thrown to the shore, and many sea animals were dead. Turtles and seabirds, they were killed. This spill has killed and disturbed the life of many aquatic animals. Again, the Erica incident is happened because of the negligence of the corrosion. The people who are the engineers who should look after the menace of the corrosion, the problem of corrosion, they have neglected, and this negligence of humans has caused the death of thousands of people in Bhopal area, and killing of animals, killing of aquatic animals, and killing of humans in life in the accident has happened. And this is why the role of the engineers or the personnel who looks after the corrosion in their respective fields should be very alert. And even if you look at the recent happening in Andhra Pradesh, in Vizag, the leakage of gas from LG chemicals, all might have happened due to the negligence of the corrosion. Now, let us see what are the consequences of the corrosion. And here I'll look at one more thing, very important with reference to the human health. The orthopedic implants, like during the accidents or replacement of some bones are required, or replacement of joints are required to cure the patients. These replacements or the repairings of the bones will be done by implanting some plates and screws, nuts, threads, etc. And these will be there in the human body for a long time. They should be very, very safe. because they may undergo corrosion and they may cause further ill health of the patients. So due to the environment of the human body or muscles or the gastric juices or whatever it may be inside our body, they may also cause the damage of the orthopedic implants. And these implants may be of different types. You can see on the slide, maybe joint replacement or different parts of the body. In the right side of the picture, you can see various parts which can be replaced. Wherever there is a change in the pH or oxygen tension in the tissues, the implants may undergo damage because of the formation of oxide layer, and this may produce the corrosion. Now, let us look at what is the cost of corrosion. Annually, there is a huge loss of money, and with reference to our Indian rupees, around 7 lakhs crores of rupees getting wasted every year because of the corrosion menace. This is about 5% of the GNP. Yes, if money is lost, we can get the money, we can earn the money, we can get the loans, or we can replace. There are two types of losses, direct losses and indirect losses. The direct losses is the material cost, maintenance cost, and the designing of the damaged machines, and the cost of material or metals we extracted. And indirectly, we have the losses by if any accident happened, the industry will be shut down, and the loss of production, and if it pharmaceutical drugs, contamination of the products may take place, or loss of very valuable products or inside the industry may be taken place. And if any material is lost, we can regain it. If any money is lost, we can get it back. And if human life is lost, just it is impossible to get it back. And let us see a few photographs in which how intensive the corrosion is. A pipeline is completely corroded and it got holes, and in the bottom picture you can see the tank is which is storing the chemicals are undergone corrosion, and the pipe it may be leaked out at any time, and the pipe has gone holes. And this I want to show the intensity of the corrosion by these pictures. Here also I have shown you some pictures in which we can see the intensity of the corrosion. Even on the right side bottom, you can see the picture in which you can see the car battery. Car battery can also undergo corrosion. If that is corroded, it leads to a major accident. Because of the formation of anodic and cathodic areas and electrolyte is available, if it spills out, it comes out, it damages the metallic part of the battery, and it may be carried over to other parts which are made up of metals. Now, with this few words, let us go to what exactly the corrosion is. And the corrosion can be defined as a destruction of the metals by the environment. By environment means is like the oxygen, moisture, and carbon dioxide, etc., which will damage the metallic products, leading to the reduction or thickness, and also the causes loss of useful properties of metals like malleability, ductility, electrical conductivity, and optical refractivity. That is, wantedly, unwantedly, or destruction and deterioration of the metallic parts by the environment is called as the corrosion. And there are few metals which will not undergo any corrosion. For example, gold and platinum, and apart silver. These will not undergo corrosion much. And let us see in further slides why exactly these are not undergoing corrosion. And These are called noble gases because they will not be undergoing corrosion. The examples of corrosion: rusting of iron and silverwares in H2S laden, air deformation of silver sulfide, etc., etc. These are the two examples for the corrosion. Now, the important thing is, why exactly the metals undergoing corrosion? What is reason for it? If you look at the backdrop of the metals, how exactly the metals are extracted? The metals are extracted from their ores. That means the stable state of the metals is there in the form of ores. It may be a carbonate, phosphate, or chloride, etc. In those forms, the metals will be stable. And we are giving some energy to it during the extraction process, and metals are separated. I say that the ores are in the ground state, and we are giving energy to the metals, these are in the excited state or unstable state. Any excited state or unstable state always tries to go back to its stable state. That means always they want to go for their combined state. That means they have a tendency to combine with any chemicals available and go and form a combined product and goes to a stable state. So only the metals have a tendency to undergo the combination or reaction with the other chemicals to form their compounds. Now, let us see what are the different types of corrosions. The corrosions are two types, generally two types. They are called as dry corrosion or chemical corrosion, and second is wet corrosion and electrochemical corrosion. A dry corrosion, name itself indicating us that it is dry and there is no water or any electrolyte, and no moisture is there. And it is directly a chemical reaction is taking place between the that is available chemical and the metal, and the reaction taking place in the chemical corrosion. In the case of wet corrosion, wet means it is any liquid will be there associated with it. That is what we call it as electrolyte. And electrochemical cell, we are calling it because whenever there is a formation of a galvanic cell or a anodic area, cathodic area are formed, electrolyte is available, then electrochemical cell is formed and the corrosion is taking place, and hence we are calling it as a wet or electrochemical corrosion. Now look, let us quickly look at these types of corrosions. Here, the corrosion, dry corrosion is taking place between the reaction between the chemical available, particularly in industrial areas where sulfur dioxide and chlorine, other gases are available, and these are reacting with that of the metals, and corrosion is taking place. This is called as a chemical corrosion or dry corrosion. This is of two types. In the atmosphere, the oxygen is available in plenty, and hence this is oxygen is readily reacts with the metals, and out of all the chemical corrosions, the prominent is the oxidation corrosion or the reaction between oxygen and metal. And in the industrial areas, the second type of corrosion, dry corrosion, whether it is with chlorine, sulfur dioxide, H2S, or nitric oxide, etc. These gases may be reacting with the metals. And other is a liquid metal corrosion, and that is when a flowing liquid is in contact with the metal, the corrosion is taking place. Let us see what exactly the oxidation corrosion is. I said that metals are directly in contact with the oxygen. Reaction with oxygen leads to a formation of oxide film over the metal. Metal reacts with oxygen to form metal oxide, and the film will be there covering the metal, and this is what we call as a oxidation corrosion. How exactly this corrosion is taking place? Metal loses electrons, what we call oxidation. Metal loses electrons and metal ions will be formed. And these metal ions, these electrons which are released by the metal are taken by the oxygen in the atmosphere, and oxide ion will be formed, and the metal ion and the oxide ion combine together to form the metal oxide. And how exactly this is taking place? There are two cases in which we should understand whether the metal ions are coming out to the surface and reacting with oxygen to form the metal oxide, or vice versa. Oxygen is entering in and going from surface to inside the core of the metal, and these two are the cases. And which case is important? In most of the metals, the metal ions are coming towards the surface, or the metal ions lose electrons to form the metal ions, and these will come to the surface where they react with the oxygen by giving the electrons, and the oxygen forms oxide ion, and the metal ions and oxide ions combine at the surface, and the metal oxide film will be formed. That is, in this, the metal ions are moving from core to surface. This happens in the case of iron, cobalt, nickel, and copper. And other possibility is the oxygen enters into the core through the surface and then reacting with the metal ions. Here, this is taking place in a lesser way, and more is metal ions are coming from core to the surface because the size of the ions, you can compare the size of the ions. And you know that metal is reacting with oxygen to form the metal oxide layer, and there are several types of these layers. Depending upon the nature of the metal oxide layer formed, the further corrosion is depending. So only this is important. And these are, some are stable layers, unstable, volatile, and porous. These are the four major types of the layers. And let us see about these. A stable film is an impervious layer is formed which checks the further oxidation of the corrosion. And in the case of aluminum, tin, lead, copper, etc., a oxide film is stable. It will not undergo any decomposition. So it acts as a protective layer. It protects the base metal from the corrosion. So it is called as a stable film. And a second case called as unstable film, the metal oxide, the metal forms oxide film, and the metal oxide is, if at all it is formed, it will undergo decomposition to form the metal and oxygen. And hence there is no loss of metal. If the metal oxide form is washed away, metal is lost. And the metal oxide film undergoes decomposition to form the metal. That is, we are getting back the metal, and hence there is no loss. So only this happens in the case of gold and silver, and hence these are very Another type of layer is volatile layer. Volatile layer. In the case of molybdenum oxide, molybdenum, which undergoes oxidation to form the metal oxide or molybdenum oxide, MoO3, which is highly volatile in nature. It escapes into the air. The solid, from solid to air transformation is what we call as a sublimation, or it is volatile. So if the solid metal oxide is getting evaporated into the air, volatilizes, and the fresh surface of the molybdenum will be exposed to the environment. And hence, again, the fresh surface is forming the metal oxide. Again, it is evaporated. Again, it is volatilized. And then, within a short time, the corrosion is taking place. And the rate of corrosion in this case is very high, very faster way. And another kind of film is porous film. That means consisting of some pores. If some pores are there, through the pores, the oxygen enters inside the body, inside the core metal, and more oxidation or more corrosion will be taking place. These are the 4 types of films. Now let us look at a rule, what we call as a Pilling Bedworth rule, proposed by these 2 scientists. And metal, they have studied much on the oxide layers. If the volume of the metal oxide is more than the metal from which it is formed, then in that case, this oxide film is acting as a protective layer and no further oxidation inside the core metal. In the first case, this is happening in the case of aluminum. And in the second case, if the metal oxides, the volume of the metal oxide formed is less than the volume of the metal, it may not be covering all the surface of the metal. And hence some areas may be exposed out. In that case, through the exposed areas, the core metal may undergo corrosion. This is called as a Pilling Bedworth rule, depending upon the volume of the oxide film formed from the volume of the metal. And in the other case, we see the corrosion by the other gases like carbon dioxide, sulfur dioxide, chlorine, sulfur dioxide, H2S, etc. This will be taking place mostly in the industrial areas. The types of dry corrosion, again, we have already seen. In this, we can see the liquid metal corrosion. This occurs due to the action of the flowing liquid metals at high temperature on solid metals or alloys. This is taking place. And the important thing is wet corrosion or electrochemical corrosion. This is taking place when electrochemical cell is formed. Electrochemical cell consisting of anodic area, cathodic area in contact with the electrolyte. The types of mechanisms of electrochemical corrosion is of 2 types. One is a corrosion with evolution of oxygen, evolution of hydrogen, and corrosion with absorption of oxygen. Let us see what are these 2. Here, in the picture, if you see the picture, the lower part is the metal and outside the upper half is the environment. In this case, the environment is the acidic solution, any acid, and the surface is clean because it is in contact with the metal, and a small area under pressure is acting as cathodic area. A small area on the surface is acting as a cathodic area, and the all remaining surface is acting as anode. The anode is large and small cathodic area. And when this happened, and these 2 are in contact with the electrolyte, what we call acid solution, and the oxidation takes place. That means the iron, if the metal is iron, iron loses electrons to form iron ions, Fe+2 ions, and these electrons will pass through the core metal, to the cathodic area, from where the electrons will come out, and these electrons are trapped by H+ ions of the acid, and H2 is liberated. This important thing is here the small cathodic area and large anodic area and acidic solution. From acid, the electrons are taken by the acidic hydrogen ions, and hydrogen is liberated. And the chemical reactions for this is just simple. Iron loses electrons to form Fe+2 ions, and H plus acid solution, H plus ions will trap the or take the electrons and forms H2. This is the overall chemical reaction involved in this. And the mechanism of the corrosion already we have by the, mechanism of corrosion by the oxygen absorption. In this case, always the metallic surface is covered with a thin film of oxide layer. And if it is not acidic environment, or if it is a neutral environment, the layer will be like that. And if at all, in any place, if a small scratch or a pore is there, if there is any damage to the layer, oxide layer, at that part, the metal will be exposed to the neutral solution. And that small part will be acting as anode. And oxidation takes place at anode. Electrons will release from the small area and pass through the core metal to the remaining surface of the metal. And from there, the electrons come out, and the electrons are taken by the oxygen in the dissolved state in the neutral solution or in the water. And that oxygen takes the electrons in the presence of water to give rise to hydroxide ions. These hydroxide ions will react with the metal ions to form the metal hydroxide. Let us look at the chemical reactions. The metal loses electrons to form the metal ions, and these are electrons are trapped by the oxygen of water and form hydroxide ion, and metal ions and hydroxide ions to form metal hydroxide. And if more amount of oxygen is available in the neutral solution, further oxidation takes place. The best example of for this is the rusting of iron. Now, quickly let us look at the difference between the dry corrosion and wet corrosion. These are very simple. It is dry corrosion in the absence of moisture, and this takes place in the presence of a conducting medium or electrolyte. The dry corrosion involves the attack of chemicals on the metal surface, and this involves the formation of electrochemical cell. And dry corrosion is a slow process, and wet corrosion is a rapid process or a fast process. The corrosion products are produced at the site of corrosion, and in the case of wet corrosion, the corrosion products occurs at the anode, but the rust will be deposited at the cathode. These are the differences between the dry corrosion and the wet corrosion. Now let us see the types of electrochemical corrosions. The first one is the galvanic corrosion, which is very important. And there is a formation of a galvanic cell. That means anodic area and cathodic area are formed in contact with electrolyte, therefore galvanic cell. And you know that anode undergoes oxidation or corrosion. That is called as a galvanic corrosion. Look at the intensity of the galvanic corrosion. A pipeline is completely corroded. A galvanized pump, and what we have zinc, and a copper pipe. Copper pipe and zinc coated pipe are connected with a liner which is made of a different metal. If two different metals are joined, then if a possible electrolyte is available in the form of moisture, then there is every possibility for the corrosion of the metallic or the anodic part. This is what we call as galvanic corrosion. An interesting thing, Gustave Eiffel and Bartholdi, they have designed the Statue of Liberty of New York, and it is made up of wrought iron, And there are some areas where the copper skin is there, and there are many parts in the statue where the copper and iron they are joined together with rivets. So in that areas, when two dissimilar metals are combined and readily available, the moisture is there in around the statue because it is erected in the middle of the sea, and hence the galvanic cell is formed and corrosion has started. And it is many parts of this statue inside undergone corrosion, and from time to time they are replacing with PTFE, a polymer, and they are protecting it as a national symbol of the United States. Another type of corrosion is a differential aeration corrosion. The name itself indicating us a differential aeration corrosion, that if air is in different quantities on a surface, metallic surface in different areas, then these two areas will be acting as anode and cathode. Very simple logic. A metallic part which is exposed to the more air acts as a cathode, and the metallic part immersed in electrolyte is poorly oxygenated or less oxygenated or less aerated, acting as anode. So if a metallic rod is kept inside the water, the metallic part which is immersed inside the water is less oxygenated or less aerated, and the metal exposed out is more oxygenated, and hence cathodic area, anodic area are formed, and corrosion takes place in the anodic area, that is inside the water. And this is called the differential aeration corrosion. Now look at some of the pictures showing the differential aeration corrosions in the industries. Metal washers, buried pipelines, cables passing through different types of soils, and the lead pipes passing through the clay and sandy soils. These will undergo, as they are exposed to the different air, they get corroded. Another corrosion is waterline corrosion. Just I told you that if a metal is exposed to different quantities of air or oxygen by submersion in the water line is the meniscus. Just below the water line, that is less oxygenated, immediately above it is more oxygenated. So the vicinity will have impact on it, and just below the water line, that part get corroded. Just I'll show in the form of a simple picture. If you take some water in a metallic vessel, just below the water line, the metal is less oxygenated, and just above the water meniscus, it is highly oxygenated, and hence lower oxygen quantities are different, and the metallic part below the water line acting as a anode, above acting as a cathode. Anodic cathodic area formed, water acts as a better electrolyte, and hence the corrosion takes place in the anodic area. The best example is, it is a metallic pillar supporting a bridge in the river, and this pillar, most of it's is submerged in the water, and the water meniscus is there. Below the water meniscus, it is poorly oxygenated. Above the meniscus, it is highly oxygenated, and less oxygen, more oxygen. Anodic area and cathodic area formed. The anodic area is below the water meniscus, and cathodic area above the water meniscus, and water is a electrolyte, and corrosion is taking place, and the pillar has got damaged. Another type of corrosion is a pitting corrosion, where it is a highly localized attack. if any dirt particles are fallen on the surface of the metal, and below the dust particle, it is poorly oxygenated, and around the dust particle, it is more oxygenated. So anodic area, cathodic area are formed, and corrosion takes place below the dust particle. That is called as a pitting corrosion. A small pit is formed. Inside the pit, the oxygen quantity is less, and above the pit, oxygen quantity is more. Again, the corrosion takes place, and the corrosion will intensify inside and into the deeper of the metal. And we can see the examples of the pitting corrosion. If any dust particles are fallen on the back rim of the watch, and then that will lead to the formation of corrosion, and pits will be formed, holes will be formed. And this will be shown in the intensified form. It may lead to the formation of holes in the pipelines also. This is another type of corrosion, glass corrosion, and we will not look at much into this. This is because of a water film formation. If any water is there on the fresh, smooth glass, that water or any withering crust will be reacting, going inside the water layer, taking the carbon dioxide, sulfur dioxide, etc., and forming some complexes with the glass material, and it will lead to the glass corrosion, which becomes opaque after some times. Let us skip off the factors which are affecting the corrosion, and let us go to corrosion protective measures. I'll just skip off few slides, please. Protective measures against corrosion. We have seen what exactly the corrosion is and what are the different types of corrosions. And now let's see in coming few minutes how to protect the corrosion. This is called what we call as a corrosion control. So this can be done by a metallic coating, organic coating, or using alloys, or electrochemical protection by using inhibitors, or using the pure metal, or modifying the environment, or proper designing. These are the different by applying the inorganic coatings or the paints and enamels, varnish, etc. We can protect our precious metals, in particular the machines. We have in metal coating, we have the electroplating, metal cladding, hard dipping, cementation, and metal spraying. These comes under the metallic coating. And in the electrochemical protection, we have two types. One is called sacrificial anodic protection and impressed current cathodic protection. In the metallic coating, we have electroplating and metal cladding, hot dipping, cementation, what we have seen here. Metallic coating is an important thing to be done to protect from the corrosion. Coating a metal on substrate metal requiring protection against the corrosion is a metallic coating. And these are types: anodic metal coating and cathodic metal coating. What are these two? If a base metal is coated with another metal for protection, if the coating metal is above it in the galvanic series, that means the coating is acting as anode to the base metal, which is to be protected. This is called as an anodic coating. And a cathodic coating, suppose if I want to coat the iron to protect the iron machine by using tin as my coating metal. So if the tin is a coating material, tin is below the iron in the galvanic series. So tin is a cathode to the iron. And if I take zinc to coat the metal, zinc is anodic to the iron. So if zinc is coated as it is anode to the iron, we call it as a anodic coating. And if I take tin and as it is a cathode to the iron, it is called as a cathodic coating. If I take zinc as the coating material, this is called as galvanizing. And the galvanization is done, that is coating of the metal by the zinc to protect it from the corrosion is called as galvanizing. The galvanizing is done by in industry. If you see, this is first the surface or the metallic structure which is to be protected from by galvanizing. It is cleaned or it is degreased. These are very big tanks in which the oils are taken, acids are taken, and these are dipped in it so that the surface is cleaned, oxidized, and then further it is taken in pickling baths where acid is taken, and these are washed, rinsed, heated, dried, and then taken into the in big tanks. The molten zinc is kept, and into that the cleaned object is dipped. For example, in this case, in the picture, you are seeing a ladder, a metallic ladder, and that is first cleaned by degreasing, pickling, and by fluxing, and then drying, and then it is dipped in the molten zinc bath. And after taking it out, it is further cleaned. The traditional picture, this is an industrial picture, and if you see our bookish picture to show the galvanizing, we see like this. First, the iron sheet is cleaned by pickling, by dipping it in by washing the sheets in the sulfuric acid, and then it is washed in the water so that the surface is cleaned, and then it is dried, and then after drying, it is passed through the molten zinc, which is kept at 425 to 430 degrees centigrade, and so that a thin film of the zinc will be coated on it, and to avoid further oxidation, it is passing out through ammonium chloride, which is acting as a flux, which is used for avoiding of aerial oxidation of the zinc. And if any further more amount of zinc is attached, sticked onto the surface of the these sheets, this will be removed by passing it through the heavy rollers, and then the sheet is annealed, that is exposed to the different temperatures, high and low temperatures. So the perfectly coated, zinc coated sheet will come out, what we call as the galvanized sheets. And let us look at quickly at the tinning. The procedure is same. Instead of zinc, if you coat it with tin, is called tinning. This is a cathodic coating. Cathodic coating. The mild steel sheets are pickled or cleaned with sulfuric acid, and then it is passed through the molten tin, and when it is getting in, it is passed through the flux, a zinc chloride flux, so that a thin film of zinc chloride will be there on the surface of the metal when it is passing inside the molten tin, and when it is, so that it will be acting for, it will be useful for the perfect adhesion of the molten tin on the surface. And when it is passing out through, it passes through the palm oil. This palm oil will protect the adhered molten tin on the surface, and also it avoids the aerial oxidation. Then it is passed out through the heavy rollers so that excess will be removed off. And now let us see that these are the huge structures. This is a Malakpet tower, a radio TV transmission tower, which is made up of iron, and the structure is very huge, and thousands of tons of iron is used for it. And this is a pipeline, and people say that the pipelines are there from Afghanistan to India, passing through the Pakistan for the transportation of the oils from different areas, from countries, and we are storing these oils and chemicals in huge tanks. And below you see the big ship made up of a huge amount of iron, and this is the power transmission lines, and big towers will be there. Transmission towers are there for transferring the electricity. So all these huge structures are made up of metal, that is mostly iron. And if any small damage is there for any of the structure, human life will be lost. The Malakpet tower is there. Suppose it's made up of iron, and a gangman is appointed to look after the safety, or a security guard is there in the campus, and he want to dry his clothes in the rainy season, and he got a copper wire, right? He got a zinc coated wire. The zinc coated wire is tied to the huge Malakpet tower, and other end is tied to a pole, and he dried his clothes. What happens? It is a copper wire or a zinc coated wire tied to the tower or a huge structure, so that the copper, the zinc and iron will be in contact. Zinc and iron will be in contact, and there forms the electrochemical cell, and water moisture will be there in the rainy season, acting as electrolyte, and hence a galvanic cell is formed. And if it doesn't matter if zinc is lost. Suppose if it is a copper wire, and if the iron is acting as an anode, if the TV tower is acting as an anode, then a small part in the joint, at the joint, will be acting, iron is acting as an anode, and it may undergo corrosion. If a millimeter of the metallic surface in the structure is lost, the balance of the tower is lost and it may fall. So with a small human error, there is a possibility for the huge damage. And even for the pipelines and these ship hulls and tanks, if any damage is there, if any small part is corroded, there is a major accident may be taken place. For this, we protect them. We protect such kind of big structures by a mechanism called as cathodic protection. And the principle involved in the cathodic protection is, we forcibly, by some mechanism, we will convert the huge structures to be protected to act as cathode. If they are acting as a cathode, another metal, another substance, another mechanism will be acting as an anode, so that the huge structures will be protected as they are acting as cathodes. For that, the two procedures we follow are sacrificial anodic protection, and the second one is impressed current cathodic protection. Let us see the simply. A pipeline is there, which is passing from state to state. From Gujarat to, we have one pipeline is there, Gujarat to Andhra Pradesh, and passing through different states, Maharashtra, Madhya Pradesh, etc. And it is passing through different soils and different minerals, and these minerals may act as cathode and making the metal as acting as anode, so that the metallic parts may act as and undermake corrosion. And if they are corroded, the gas or oils may spill out and come out, and leakage may take place. So to avoid this one, these pipelines are huge structures which are to be protected, are connected to any material which are anodic to the iron. So that suppose in the case of the figure we have seen magnesium. If magnesium is anodic to the iron, and if they are connected, the magnesium acts as anode, and it undergoes corrosion, and it is getting exhausted, and the metal pipe will be acting as a cathode, and it will be safe. See, this is a process. A pipeline is there, showing red color, which is from in different intervals, different places. This pipeline is connected to another metal, which is shown in a bag, in the form of a bag, and magnesium is kept inside and connected to that pipeline, so that the magnesium are acting as anode, and if any corrosion is there, anode undergoes corrosion, and the red color pipe will be protected and from the corrosion. And these are some of the pictures taken for showing you the sacrificial anodic protection. In the first picture, you see a white color small pin is there that is connected to a big pipeline that is made up of anodic metal to the base metal pipeline, so that if at all any corrosion is there, that will be sacrificed in himself. The anode is getting sacrificed, or it is undergoing corrosion and protecting the huge structure, and hence this is called as a sacrificial anodic protection. And in the right side picture, you can see the iron pillars supporting a bridge having, you can see the white color flaps for each pillar. You can see different 2 or 3 flaps are there. These flaps are connected to the base metal. These are anodic metal to the iron. It may be a zinc, or it may be magnesium, or a calcium, whatever it may be, that is there in the made as a flaps and connected it, so that any corrosion is there, then only the flaps or the connections will be getting damaged, or anode will be getting damaged. Second is impressed current cathodic protection. It is another mechanism by which we are making the huge structure to be protected as from corrosion by making to act as a cathode. And you know the reversible cells. A cell is giving anode and cathode are connected to are there in the electrolyte, which is giving a current. Suppose it is giving a current of 1.1 volts, say galvanic cell, and which in which copper and zinc or anodic cathode and electrolyte is there. And if at all these 2 wires are connected to external battery, and if you adjust its EMF value as more than 1.1 volts, say 1.1001, infinitesimally more than that of what we get, so that this galvanic cell will be reversed, and this will be, anode will be acting as a cathode, cathode will be acting as anode. By taking this as a principle, we connect a neutral metal to the huge structure or pipeline or a tower, and these 2 are connected to a battery, and its EMF value is adjusted in such a way that the huge structure will act as a cathode and the neutral metal act as a anode, so that nothing happens to neutral metal or nothing happens to the huge structure. What is lost? What is exhausted? The battery will be exhausted, and from time to time the battery's life is checked and replaced with other battery, so that it is as impressed is opposed, as we are opposed current is sent and the huge structure is made as a cathode. This is called as impressed current cathodic protection. This is shown in the form of a small diagram, and this is a objective protected, and the protective current is passed, and the rectifier means a battery, and the battery is adjusted in such a way that you are forcing the huge structure to act as a cathode. And we have the another methods to protect the corrosion are electroplating. We plate the metals with a precious metal so that they are inside the base metal is protected. How it works, and this is we don't have any much time to explain or to go into the details of the electroplating, and we can see this is a simple example. This is, we have taken gold cyanide as solution and a copper coin is taken as a negative electrode, and if we coat it, the copper will look like a gold. So we have coated the copper coin with the gold by taking gold cyanide as a electrolyte. So the gold ions undergo oxidation and goes to the cathode, where we have a copper, and at that cathode get reduced and get deposited. And another method is electroless plating. Here in the plating mechanism, we have the reduction process. The metal ions are there and they'll get reduced and get deposited on the surface. This is a mechanism. So if without using electricity, if any reducing reagent is added, suppose I have taken gold chloride. Gold chloride solution is there. In that I kept a copper wire, a copper coin. And if I add a reducing reagent to it, the gold ions will get reduced and get deposited on the copper coin, and this is called as, that is, if you see here, metal ions will be reduced by the reducing reagent, and metals will be separated or deposited, and this is coated on the surface. And without using any electricity, and by using the reducing reagent or a chemical, deposit is done. This is called as electroless deposition, electroless plating. And here you can see these different colors and how decorative these are and how smooth finishing they'll be. And a silver plating is there at the bottom. Before plating, after plating, you can see how they shine, and these are both decorative purpose and protective purpose from corrosion. These are used. This is all about the plating. We have much progress and much technology is developed, and this corrosion is very, very important. And because if you lose the money or if you lose the material, we can get it, but if my life is lost, we cannot get back. And hence human life is very valuable, and hence we should be very careful and we should concentrate on the corrosion much. Here is a small joke for you. Well, we did not change. You told me that your car is rust free. Okay. With this, I'll say thank you very much. This is the end of the session. Thank you so much.
Thank you, sir.
Thank you, sir. Thank you. Thank you very much, sir.
Can I sign off?
Yes, sir. Fine, sir. So, Madam, what are things? Yeah, please.
Yes, sir. Yes, sir. First, sir, before that, one small announcement. To all the participants, we'll send the feedback links to your registered mail IDs, and also it's sent it will send to your chat box. Okay. Then we don't worry about the feedback links. And after submitting the feedback forms, you'll get the e-certificate. And here someone having a doubt, Praveen Challa, then raise their hand. Okay, now it's time for vote of thanks. Okay, first, thank you very much, sir, for your valuable and kind words. We all are really very inspired and motivated.
Thank you.
The course content, like corrosion and the prevention methods, traditional prevention methods of prevention methods, is excellent, and the detailed explanation. We are very fortunate to today's session. And I, on behalf of Vageshwari College of Engineering, seek great pleasure to extend vote of thanks to everyone for this webinar. We have been really very fortunate to have the eminent speaker for today's webinar. First, I would like to sincerely extend my thanks to our eminent speaker, Professor M. Tirumalachari sir, HOD of Chemistry Department, JNTH College of Engineering, Hyderabad, for kindly accepting our invitation. And gracing the session in spite of his hectic schedule. Thank you very much. And I heartful thank our secretary, sir. Our secretary and correspondent, Dr. G. Srinivas Reddy Garu, and Joint Secretary Sri D. Srinivas Reddy Garu, for his encouragement and providing necessary facilities and support to organize this webinar. And I'm thankful to sincere thanks to our principal, sir, Dr. C.H. Srinivas Garu, for his continuous encouragement, motivation, and support to organize this webinar. And I thanks to ECHOD Venkat Reddy sir and faculty GS Arun Kumar sir for technical support to making this webinar successful. And finally, and it not least, thank you very much to all the participants for their active participation and taking part in the webinar. And congratulate all the participants. And heartly congratulations to all of you for taking an active participation in this webinar. Thank you. Once again, thank you very much to all.
Thank you so much, madam.
Dear participants, please, is already feedback link posted in chat box. And also we sent your registered mail IDs. For your convenience, thus we have divided groups, the participants divided as a groups. So here 4 links are posted in chat box. You can take any one of the link, you get the feedback form. And after submitting, you... Here Shirisha madam has raised her hand. Then please unmute yourself, ma'am. Please unmute yourself.
Or else, Madam Shirisha, you
Or
can.
else you send message.
Yeah.
You can send a message in chat box. Okay, we already sent feedback forms, feedback links in chat box, through chat box, and also we sent already all the registered mail IDs of the participants. Okay, sir. Shall I end the session?
Okay, sure.
Yes,
Thank
ma'am.
you.
Thank you, sir. Thank you.
Okay, sir. Thank you.
Vimal,
Thank
sir.
you, sir. Thank you very much.
Thank you, Srinivas sir. Thank you.
Thank you, sir. Thank you, Vimal, sir.
Hello, Anna.
Sir. Sir. Good morning. Good morning.
Okay, Anna.
Fine.
ఇంట్లో ఉన్నావా?
At home. At home. అంతే ఇక వెళ్ళలేదు కాలేజ్కి వెళ్ళలేదు డైలీ వెళ్తున్నాం బట్ టుడే స్టేడ్ హోమ్ రైట్ మండే అగైన్
విన్నావా? వాయిస్ క్లియర్ ఉందా?
యా హిస్ వాయిస్ గుడ్ వెరీ గుడ్ ఉన్నాను కంప్లీట్ సెషన్ వాస్ దేర్ కంప్లీట్ సెషన్
ఓకే అన్న.
వాస్ నైస్ వెరీ నైస్
ఓకే, నేను స్టిల్ రికార్డింగ్ కొని చెప్పాను.
Yeah, okay, it's a record. We can end the session, right? Okay.
Okay, right.